things that really wants to make notes as well. So basically, I've just been asked to cover sort of the basics of explosion protection, going a little bit into zones, all the different explosion protection methods that there are, and go a little bit into ice barriers as well. So I've got some examples, again, I can show around as we go through. If that starts working again, because it stops. Yeah, that bit works. Do this way. So yeah, we all know the explosion triangle is, you know, pretty basic. You need three things to create any sort of ignition, fire, explosion, etc. So you need the air, plenty of oxygen, some fuel, obviously whatever the process is, and some energy. And you get all three together, and that's your explosion. So I've got a quick YouTube video just to show. So this just sort of emphasises that. You may have seen this before, you may not have done. There's a young lady in America refuelling. As I'm sure some of you know, in America you can put your pump in, click it on, and it just whirs away. You can then go and sit in your car. You can wiggle about, build up a nice bit of static on yourself. A lot of people apparently, as they get out of the car, tend to sort of lift themselves out, and so of course they earth themselves. But in this particular instance, that doesn't happen. So yeah, just sitting in there, wiggling about, building up a nice charge, gets out, adjusts the jumper as well.
Ooh.
And I like the way she tries to blow on it. I think that's quite useful. But yeah, so it really doesn't take much. Yeah, that's just
It's a burden upon the cars have gone up.
Yeah. I was actually thinking about showing, I don't know if you saw on the BBC News, there was the Ukraine ammo dump.
Yeah,
Yeah.
saw that.
That was quite impressive. So yeah. So you see what happens. So you see what happens, obviously, when you get all three come together. So going into sort of zoned areas, how it's classed. I'm sure as you know, it's different in the UK as opposed to in America. Being Americans like to have slightly different standards. But generally speaking, in the UK we have obviously zone 0, so there's an almost definite chance that there's going to be hazardous material. Zone 1 tends to be around connections, valves, flow meters, anything where there's a potential for leak, and then Zone 2 just going out of that area for a little bit. And as you can see here, as we say, there are a few regulations that you can read through to try and understand this in more detail, but again, that's quite a long lesson in itself. From our point of view as PEPPERL+FUCHS, as a manufacturer, we supply equipment into these areas. It's not up to us to come along and say what's a zone 1, what's a zone 2, etc., etc. So that's normally up to the people on site. So when we go back to the explosion triangle again, basically you take one of the three units away, and then you create a safe atmosphere then. So the main ones that I'm going to go through are obviously the main ones that we manufacture. So that's intrinsic safety, XI, containment or explosion proof boxes, XD, and we also deal with purge systems as well. Purge doesn't seem to come up too much, but it's worth just knowing about as well. There's other protection methods as well. I won't go too much into detail, but basically you can immerse in oil, you can powder fill for EXQ, so in essence you're eliminating all the air from the area. Yeah. EXM, encapsulation, don't know that one. Increased safety, so EXE. I've actually got an EXE box here. If you want to pass it around, feel free. Not too bad. The door may come off because it's on a hinge that you can lift up. But basically that's an EXE box. EXE is particularly good if you're putting equipment in which is certified for EXE. So, for instance, our barriers normally go in the safe area and transmit out into the hazardous area, but with an EXE box, you can put the barriers inside there. There's a specific special condition on the certificate. If anyone has any particular questions or queries on that, you can ask me later on. and you've also got EXN, sort of ignition protection, which is a bit of a mixture. So explosion proof, so EXD boxes. This is what you tend to see on a lot of large sites anyway. So in essence, explosion proof EXD, so you can use the zone 1, zone 2. Yeah, like I say, the lid will just lift up if you're not too careful, but yeah. So with EXD, the idea is we're actually allowing the explosion to happen, but we're allowing it to happen within this EXD enclosure. Around this flange of the enclosure, you'll see flame path. So this is a very smooth piece of metal, specifically manufactured to match the lid. The idea being that you leave a nice gap so that any energy that's built up inside the explosion can go through the flame path, but by the time it reaches the explosive atmosphere, it's all dissipated and there's not enough energy now to create the explosion. And again, another nice little issue there. These are all bits of mixing up in little bits.
Every design is tested to ensure that it can hold pressure and contain an explosion. An explosion-proof window has been installed.
So yeah, so we've got an EXD box, you can see all the bottom box around the edge, and this is the flame path that I was talking about. They put a window in there and then just put a little spark plug in there, just to ignite it. So there you go.
This is followed by a water pressure test, in which the enclosure is subjected to a pressure of 4 times the maximum explosion pressure. Another test is performed.
So this one, they've got like a canopy see-through tent, basically pumped in an explosive atmosphere.
In this test, the enclosure is surrounded by an explosive gas mixture inside a plastic tent.
Thank you.
Note that the internal explosion is not transmitted to the outside explosive mixture. Now,
So then what we're going to do is put a damage
the flanged
into the flame path, so there's now a scratch. It's not a very big scratch, but now in theory that's enough energy can now explode, get out of there. So I say it's only a small scratch, but that's enough to make such a difference. Which is why, especially with EXD, you have to be very careful with installing and making sure that those surfaces are all safe. So yeah, some examples of EXD. It's also possible for us as a manufacturer anyway, we can do EXD and E enclosures flanged together. So in this instance, we've got 2 boxes and we've got some lime bushes in between. Nowadays you can flange them as well, so you can have an EXE, so it makes it nice and easy for installation. You can put a few push buttons on there, and then any other equipment you can put into the EXD, so this way you're saving a lot of space. Yes?
Why have you got gasketed doors when to propagate the flame to the outside, the flange is so critical?
In this one, that's probably an EXE box, I think, for that one.
The one you're circulating has a gasket in.
Which one? This one?
No, the one you're circulating around here.
Oh, sorry, no, that's an EXE enclosure.
Yeah, sorry.
So yeah, that's an EXE, so this is the sort of increased safety. EXD I would bring, but they're very heavy. Like I said, I think we have a box in our office which is sort of so big, and I think that weighs quite a few kilos. And
So the bottom right-hand side one showing the gasketed doors is not EXD. Bottom right-hand side.
Bottom right.
This one.
Yeah.
But I'd say this is probably a mixture of EXE and E.
There's no gasket on that, Alan.
Yeah, there's a gasket around the
Looks
outside.
like it could be. Yes.
Possibly. This is an older presentation, so in fact I think I've probably got a better picture.
Yeah, it's the bottom right. There's sort of that pack of 3, isn't it? There's an EXD one on the left. The one on the left-hand side of the 3 is different from the one on the right-hand side.
It
Might just be the ground surface and not be a gasket.
Yeah. That's just a sort of typical example of D and E put together, so you can put
So are there any approved methods of stopping moisture getting in?
they're all IP
Denso
rated.
tape.
Yeah.
Then some tape. Yes.
They have to be meet a certain IP rating, so I think ours are IP 66 or 67 off the top of my head.
That's the next question. Does Denso tape?
Yeah, people have.
Yeah, that's right.
But again, You have to be careful because one of the other parts of an EXD box is static build up on the surface.
Right.
So, for instance, we on any labelling we have to use very specific materials. We have noticed that some, with supply box, and people put their own sticker on, but you have to be very careful because if someone comes along and wipes that, builds up a bit of static. It can happen. You can get around that by as long as you put another label on saying clean with a wet moist cloth or something along those lines. But yeah, so EXD, you can do EXD-E solutions as well, and obviously EXD as the box was. Sometimes EXD will get you so far, but sooner or later it's going to get just too big, too heavy. So this is where purge typically tends to come in. There's a few more limits, but there's a few more advantages, so it swings and roundabouts really. So with the purge, you often take a sort of very large enclosure, say like a metal size enclosure. And on initial start, what we do, close the door, seal it all up, then have a purge controller which will pump in 5 times the volume of air. Do you like the sound effect? That's quite good. And yeah, you basically get as much of that atmosphere, or potentially explosive atmosphere, out of that enclosure, and you then maintain an overpressure. I don't know who put these in, but you maintain an overpressure, just a few millibar, but it's enough to make sure that that explosive gas can now not get into that enclosure. You've then got pretty much a safe environment, depending on what area classification you're in. Typically it knocks it down one. There are a few limits. Like I said, you do need a clean air source on site. Some places have that, some places don't. We have heard of places where they've just got a compressor line next to it in the hazardous area, it's just pumping in the gas. So it's not really doing much, but there you go. And also, you could be out on site in the middle of a desert somewhere, you might not have a compressor anyway. So there are limits. You can also, when you open the door, obviously that has to shut power off. There's no remark switch in there, so that will just kill power. Some people don't like that because then you might need a shutdown sequence, say for a PLC or something. But again, you can get around that by putting perhaps an EXD enclosure inside of a purge enclosure. So there's a few different ways and means of going about things often. It's not something that comes up often, like I said. There tends to be, people try and avoid purge, but it's a good way of doing things sometimes. So this is a typical purge solution. So we've got a control unit, so we've got all of the electronics, control valves, etc. in there, a vent on top. So this is the customer's enclosure. This particular one's just quite a small one. Obviously you can go quite large. So yeah, it's basically just controlling the airflow, going into the enclosure and then out through the vent, and then that maintains an overpressure. Modern purge units, again, very clever nowadays. Our latest one's got Bluetooth technology, so you can use a hazardous area tablet, connect to it via Bluetooth, and you can download settings and programs and do all sorts of weird and wonderful things. You can also have temperature sensors inside the enclosure, so if perhaps you're trying to maintain or you're worried about something overheating, you can have the temperature sensor nearby. That will then feed into the control unit, and if the temperature reaches too high, it will then go through a cycle and blow some cooler air in to cool that down as well. And then into EXI, into barriers. Does anyone have any questions on purge, by the way? Like I say, it doesn't come about too often, but it's handy to know about when it does. So I've got here some sort of EXI barriers. Those are the typical sort of K series that probably everyone knows, especially P&F for. Other manufacturers are available, but they're not very good. We've also got like a H series. This would sit on a terminal board and connect directly to DCS manufacturers, but it's basically the same thing, but in different package. I'll go on to some other products later on. So with EXI, obviously what we're trying to do is limit the energy that's going into the hazardous area so it doesn't create an explosion. This particular graph shows ignition temperatures, so especially with EXD we have to be aware of the surface temperature of the box. If you especially in this lower range, then you have to be very careful. if you think of as something simple like hydrogen, it's got very high ignition temperature. However, when you look at the energy, very, very low. So it's always something just to be aware of depending on what area you're working in. So intrinsic safety, like I said, EXI, most people know it as EXIA, I'll go through that in a minute. But basically what you're doing is you're limiting that energy, the voltage, the current, the power going into that hazardous area through a barrier of some sort. Now, we have to make sure that this pairs up with anything going into the area, any sensors in the hazardous area. I'm sure most people are aware of this, but we do have people that say, you know, my flow meter's not really working properly, and we look into it and they're just using a standard flow meter in a hazardous area and then got a barrier, and they think that's a suitable solution. It's not, unfortunately. The reason being is that the electronics within that flow meter, for instance, there's a capability there to store up that energy going in. So if you imagine a trickle charger going to a car battery, you just short across the trickle charger, small spark, short across the battery, big spark. So you have to make sure that the two are paired up. So we always look at the documentation. A customer should always look at the documentation, so you're looking at the voltage, current, power, and you're also looking at the cabling as well, if there's a particular large length of cabling, because again this can all store energy. And then you'll always find these details on any certificate. Sometimes you'll see them on a website or a data sheet. You're always best off just going to the certificate, because that's the gospel, I suppose, as it were. And then once you've got that, you then make sure that your barrier matches up. So again, the barrier will have maximum outputs, so other than the field device which has inputs, this is the outputs. So you're making sure that whatever's coming out of the barrier doesn't exceed whatever can be accepted by the sensor. So for instance, with one of our barriers, like I said, you can go onto the certificate and you'll get all the values on there. So then we have an intrinsically safe circuit. So we have in this case, a pressure meter. You've got the barrier, so your barrier going off into the hazardous area. So we're looking at making sure that the values UI and UO are acceptable and working the way through it. So this should be done by people in the field. We do get asked, can we just go through and check people's calculations just to make sure? We can check, but it's not our job, it's not our signature going on, basically, in the end of the day. So it's always best to make sure you know really what's going on and what's happening. So just a few examples here. So we've got our field device, just a little sensor in there, and the barrier. So we've got 30 volts that can be taken by the sensor, and we're only kicking out 28, so that's all good. 110 and 93 milliamps, fine. 770, 660. So that one's safe. All is good in that. B, exactly the same, because we are equal to, so we are equal, equal, and equal. When it comes to example C, we're equal on voltage, absolutely fine. As soon as you look at the current, well, we can only accept 93, but the barrier's kicking out 110, so immediately that's no good. You can go down to the next one if you want it, but there's no point because you've already exceeded something, so not safe. Go back. Yeah, unsafe. There are exceptions to the rule. Within the ATEX directive, you've got simple apparatus. Now, it's always a bit of a, how do you interpret what's a simple apparatus? So the way some of our colleagues over in Germany say it is if you have to ask if it's simple, then it's not simple. So it's going along now. Let's do this thing. So some simple apparatus examples. So a device that will not generate nor store more 1.5 volts, 0.1 amps, 25 volts. So anything very simple switches, thermocouples, etc., this kind of thing. You can go into volt-free contact, so thermal switches, the kind of things you see on your kettles, bursting disc, etc., etc. Yeah, we did this presentation in Ireland, and everyone laughed when we said mercury tilt switch, because it's something that's found for obvious reasons. Yes. But yeah, so like I said, there are various examples of simple apparatus, in which case it's all okay. You still need the barrier, but you know, you can have this as a non-certified piece of equipment.
Transistor switch intrigues me.
Oh, want to go back one?
That I would have thought that transistor switch, unless you've got a very, very low power transistor.
There's probably limits in there. Again, if you're not sure, then that's when we could go into check it. If you're ever not sure, then we've got a technical helpline that you can call up, and we can give advice and say, you know, you can have a look at the data sheets.
That's pH probes. pH probes is a simple device.
Potentially, yeah. I mean, you could, like I said, you can use a thermocouple as a simple device, but if you've then got the puck on top, then that's now got electronics.
Just the probe.
Yeah. But as soon as you put in electronics on it, then
That's a
it then
different
goes,
matter.
yeah, that's when it goes into a different matter. Other examples: reed switches, door contacts, level detection. Again, it's a bit of a level switches, simple. Yeah, fine. Obviously, an ultrasonic flow, device or something. Then no. Again, speed monitors. And then you're going into certified equipment, so any numerous sensor. Obviously, we put this up because we also do numerous sensors as well. So yeah, they are as they are, shafted cameras. Now, when it comes to barriers, I'm sure as you're aware that there's basically the two types. We have Zener barriers and galvanic isolators. We do get quite a few queries from. It typically tends to come from customers who haven't really dealt with this very much. They're trying to figure out whether they need to use a Zener or whether they need to use a galvanic isolator. So a Zener, in essence, a very simple device. So they typically tend to be a bit more cheap and cheerful. So you have Zener diodes, and these just act as a sort of pressure relief valve, I suppose, in the system. So if any power gets too much, it goes to earth and doesn't go off into the hazardous area. They're very, very simple devices. It's typically what goes in is what comes out. But you do have, you do have different options. The reason, I don't know if anyone ever really noticed, but you tend to see EXIA devices. You don't tend to see IB or IC. The reason being is that it comes down to how many faults you allow within the device. So with an EXIA, we've got 3 Zener diodes, so we allow 2 of them to fail before we've still got 1 left. With an IB, you only allow 1 fault, and with an IC, no faults. Now, typically, the reason I say this is that with most manufacturers, the cost of a Zener diode is fractionally few pence. It's negligible, really. So pretty much everyone now just builds into EXIA and has the redundancy in there. Zener earthing, this is where it sort of gets a little bit trickier, I suppose. We typically tend to see Zeners on old sites, places where this has been going for years and years, and it's just a case of we've always used Zeners, we'll just keep chucking those at it. And it's just fair enough, sometimes if it doesn't work, don't fix it, as it were. But there just needs to be a few bits that people need to be aware of when it comes to the earth, because that's the main part. So this has to be at least 1 copper conductor, not less than 4 mil squared, and it can even increase to 16 mil squared of copper. Or you can have 2 separate conductors which are not less than 1.5 mil squared. Most places will know what their general earth is, and this also needs to be a separate earth as well.
Is that assumes that your common bus bar is going to be in the panel where the Zener barriers are?
Yeah. Again, we've got. I mentioned it now. We've got an engineer's guide, which is a very thick telephone directory-sized book. I'm sure a few of you may have 1 or 2 knocking around our office, in your office, but unfortunately we don't print them anymore. I think we're trying to save the trees. I think it took probably half of the Brazilian rainforest for us to print these things. So we don't tend to print them. There's a lot of hassle to keep them updated because a lot of it is the data sheets for the barriers, which obviously get updated every now and then. But I do have a PDF copy, and in there the first section goes into a lot of what this goes through, and more advanced obviously. So if anyone wants a copy of that, just let me know and I can either email it. It might be a bit too big to email, but I can give you a link to a Dropbox or something along these lines, and you can print it out if you've got enough paper in your office. It's about 700 odd pages, so it's fairly chunky. But yeah, it'll go into more detail on Xena Earthing if that ever comes up. Yeah, separate earth paths, so you just need to make sure that any equipment is separate, so that one doesn't hopefully feed back through. There's, again, I could go into this for, well, we've got technical guys that can go into this for quite a while. I'm a sales guy, so I know the basics, but I don't want to go too much into too much depth. So most of the advantages with Zen is it's very cost effective. You know, these are typically sub £100 pieces of kit. They're very, very small. They're typically application specific, i.e. what goes in comes out. But you do need the ice ground. There's no sort of clever tricks you can do with any signal conditioning. There's an obvious voltage drop, and if anything ever goes wrong, you have to replace it. Just go through that. So yeah, there's digital signals, analogs, etc., etc. Yeah, I'll skip through these, but digital inputs, so Rockfree contact, etc., etc. Coming in, digital output, so solenoids, anything you're driving really. Sounders, beacons are the typical ones we tend to see most. Solenoids, so as long as they're capable of taking that power. Analog inputs, so your typical flow meters, pressure meters, etc. And analog outs, so any sort of display, positioner, anything along those lines. So these are the Zenas. You can also get dual channel units, so if you know, save yourself a bit of money as well, and reduce the size of the amount that you need. If you've got lots of them, you can use 2 channels. And yeah, check an engineer's guide, like I said. Our website's pretty good as well, you can go through that as well. And then into the ice barriers. So this is basically how the galvanically isolated barrier works. This is the one that I passed around. So you've got the typical Xena situation here, but then you also have the galvanic separation, you have amplifiers, and you can do more trickery with it afterwards, so you can do relay outputs, you can do displays and signal conditioning basically. So if anything ever goes through too much, then it just goes straight out. You don't have to worry about these things as much. And some of them, yeah, you can do quite a few applications. So you know, this is one of the more sort of all singing, all dancing. So you can take one input, you've got relay outputs, display on the front, which I think will show, yeah. So for instance, like I say, with speed monitor, you can do RPMs. You can convert that into flow rates if you've got certain types of flow meters, whether it's hertz, etc. So 2 trips out, and you can convert the signals as well. So there's lots you can do in a relatively small device. We have hundreds and hundreds of different types of barriers, so the chances are there's something that will do what it is you need anyway. Start, override, etc., etc.
So what you've got then, you've got your interface with the hazardous area in a particular part of that unit, and the subsequent processing of the information in a different part of the unit that's sufficiently isolated.
Yeah, well basically, I mean, this would sit in the safe area, so anything coming out is going into the hazardous area, so this is where your sensors sit. So the galvanic isolation is in here, but then you have all the trickery before that. So yeah, you're basically isolating, making sure that obviously anything doesn't feed through into the hazardous area. You can get units which are very clever now and can do fault monitoring, so you can do lead breakage or short circuit detection as well, and they can then go out as either a relay signal, or on our barriers we've got a power rail, so you can send a signal through the power rail and off to the power feed module. I took those slides out just because of the sort of length of the presentation, so but if anyone has any questions on that, I can show you something later on if needed. What's this one? Yeah, so with a barrier, like I say, you don't need to worry about the ice ground, which is a lot easier. Fuses, even when they go, you can replace them easy enough. Factory serviceable, we don't tend to see these come back very often, unless someone's made a mistake and wired them up wrong, in which case the cost of repair typically just say, well, just get a new one under warranty. And like I say, we've got an engineer guide. Yeah, basically, like I said, I've got a PDF copy, so if anyone wants it, because we can't download these anymore, because I think it was just the hassle of keeping them updated. So this is probably 2012, I think. So we do have more newer barriers coming out all the time. But it goes through the basics. Like I said, the engineer's guide, the ATEX guide at the beginning is particularly handy. Yeah, technology section. So it goes through an introduction to intrinsic safety, and this is quite a few pages. We've got basic principles, EX protection, functional safety, SIL. That's something for people want to read and before they go to bed. That's always a good read. And there's also an application guide in there, which is quite good as well. I think I might be going ahead of myself. Yeah, so it goes through all of the theory, so it's basically a more expanded version of what we said here. Application practical solutions. So if you want to know how to do a specific job, temperature sensor, what barrier to use, you want to read the output, which one to use, etc., you can go through all these and it gives examples. And again, we've got a technical helpline support number, a couple of guys in our office, very well versed in barriers and out of the, like I say, a few hundred barriers, they know each one and what each one does, so they'll be able to select the right ones for you if you've got any questions. So yeah, typical, it sort of repeats what the Zeners do, but basically digital inputs. So if the signal's going into the unit coming from hazardous area, so that's the voltage contacts, the sensors, etc., signals going out to the field. Yeah, samplers, beacons, LEDs. We have seen recently a few customers requesting about the horns and sounders, this kind of thing, because obviously they want to try and put perhaps 2 or 3 of these on one output, but obviously you're using up a lot of the energy there, and all you get is a very weak board just going and not really doing anything, so you just have to be careful. Yeah, wire solenoids as well. Analog inputs, so anything coming in, so your typical 2 or 3 wire transmitters. I think it's got other bits as well, so any sort of 4 to 20 loops, detectors, signal splitting, so perhaps you can have 1 signal coming in, 2 signals going out, signal conversion, volts to current volts, and HART as well. A lot of places still use HART, and it's out there. A lot of the devices we have can take HART signals as well. You just have to check on the data sheets. Again, any questions you can ask us. And then analog outputs as well, IP converters, positioners, etc., displays, that kind of thing, etc. So we've got our website. I think our website's particularly good at the moment. We've got quite good selection tables, so for the barriers, but for other bits of equipment as well. We also do HMIs, hazardous area PCs, remote monitors, all sorts. So there's lots of information on there. We've got all the data sheets, we've got all the certificates, and again, any questions, just give us a call. I think, how was that done? Not too bad. So I think that basically covers just the basics. Like I say, if anyone's got any particular questions, feel free to ask. Any questions? I think most of it you guys should probably know anyway. What we do is, like I say, we can go into it in a bit more depth if anyone wants during the lunch and learn. We do these with customer sites. We can do these over an hour, hour and a half, 2 hours, depending on the sort of questions. And we also have a day-long course. We've got the next lot coming up in the 2nd week of November. So we have a guy from Germany comes over, a guy called Michael Vengelors. He sits on the TUV board, and his job is doing these courses. It's a day-long course. It's free lunch as well. And the idea is basically what we've gone through here, but in a much more depth. And it'll go through a lot of the legal basics as well. So we do that on explosion protection. And there's also a SIL version as well. If any, you're starting to use SIL quite a lot on sites. I think we'll be doing it. like I say, second week in November. I think then we'll be at the Wilton site, so not too far away from here. And I think we'll then be doing 2 days down Sheffield and 2 days in our office in Oldham. So if anyone's interested, again, just send me a quick email and we'll put your name in when we send any invites out. So yeah, I think that pretty much covers it. Any questions, queries, comments, issues, applications?
You mentioned Hart. What about the field bus? Where does that?
We do have equipment for field bus. We don't see it as much. We tend to see more what's now known as a remote I/O system. So we do still have field bus equipment, field bus junction boxes, couplers, etc., etc. There's quite a lot of equipment in there. So yeah, that is part of it, but I didn't want to go into more depth into the basics. If you've got field bus equipment on site, then that's no, because there's quite a lot changed over the years. So yeah, it's something we do. I think in the brochure I've got down there, we've got a little bit on there as well.
Does your handbook cover anything about formal design validation?
I don't believe it does, because we're a manufacturer.
Yeah.
We've got the guys in Germany which will design
It's an
equipment.
area a lot of engineers don't understand the necessity for.
Yeah, well, like I said, we'll do on our day-long course. I think it goes into it a little bit, but we tend to find if you're going on the designer's course, and typically you need to go on the complex courses and this kind of thing. Like I said, we can give you a bit of information, because there's a lot of people that perhaps new to hazardous areas, so they send an engineer out on a complex course, and he goes off for the week and he thinks, oh, it's just easy, I've just got to turn up every day, gets to the end, does the test and fails. It's, well, you know, it's way over my head. So we can do a little bit of basic stuff, like I said, a bit more of this, but advanced, just to give them an idea, and then the day-long course, and then that then feeds them into doing a complex course or something a bit more design advanced.
What's going to change in the next couple of years?
If I knew that.
What's coming through the system?
There was an update to the ATEX directive about 2 or 3 years ago. Now, we were questioning, I think, as to how that change affected us. Any equipment in the field or was already certified is absolutely fine. So, for instance, most of our barriers have not been updated for the last few years, so they'll be fine. However, anything new coming out needs to be up to those new standards. The exact difference between the two standards, I couldn't tell you exactly. So we've got guys up in our head office in Germany who deal with this side of things, and lots of letters after their name and go after all these details. So other changes, we don't tend to see much foundation field bus technology anymore. So that seems to be dying away a little bit. So we still have Profibus, we still have Modbus, these sort of communication standards. It seems to be going over a little bit more into Profinet and Ethernet, so basically internet-based communication. And I think there's also there's quite a lot of demand. Well, I said it's a bit of demand. We see it, but because we're a manufacturer, I suppose. We recently bought a company called Ecom who do phones and tablets for hazardous areas. And there seems to be a lot more interest in trying to integrate everything into like the computer system. So rather than your engineer going out to site, setting up an instrument, making some notes, going back, writing it all up, writing reports, blah blah blah, you go out, you take your tablet, you tap it all in, and it's done, and it all just syncs up. You know. So that seems to be the way a lot of people are interested in managing big sites, and you can understand why. We've heard of applications where there's been a shutdown because of a fault, so someone's had to go out middle of the night or something, try and figure it out, go back to the safer, make a phone call, you know, take a few hours, try and figure all this out. I mean, in that time, obviously, the plant's not running, so you know, plant might lose a couple of grand, 40 grand, 100 grand, who knows. Whereas with a tablet, you can go out to the field, you can Skype, you know, someone, you can say, look, this is what's wrong. Oh, right, okay, you need to do this, blah, 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 fixed. So that whole sort of communication way seems to be what we're seeing in demand anyway. And like I say, the whole building it up into the computer system, or whatever computer system you've got on site.
So those portable devices, are they going to be suitable for zone 1?
Yeah, I've got, we've got, that's a Zone 1 mobile phone. So it's an Android based mobile phone. That one's Zone 1, we also do Zone 2. Tablets, the Zone 2, Zone 1 versions. They're typically Android devices. We do a Zone 2 Windows because that seems to be what most people sites
So
want.
is that actually intrinsically safe? Or
it's-
is it something else?
It's a mixture of EXD. I think there might be a bit of EXQ in there. I'm not sure. I think it might say on the back somewhere in terms of the.
Because it feels heavy enough.
Yeah. Oh yeah. Yeah. I mean they're pretty chunky pieces, and they go through a lot of testing. There's a video on the Econ website.
It's not got to split in two when you drop it from a height.
No, you can pull it out. It's a bit stiff just because it sits in my bag. To be honest.
Come out, you beast.
There you go.
Smart EX. EXIB 2CT4 GB IP44 2D.
Can't drop it in a bucket of water.
No,
Yeah. For the testing that they do.
I
for these things,
need a new degree to read all those numbers.
There's a little poster up the front here which might be of interest because it goes through what each one of these means: EX2D, T4, etc., etc.
What's the G and the B?
The G is for gas, I think. Oh, GB, sorry. It's for. I have to try and remember myself now. Equipment protection level.
Gas zone 1, isn't it?
Yeah, GA is very high level, so that would be typically zone 0, zone 1. GB high level, and GC
Right.
increased level. So. But yeah, you can help yourself to those. As
So
well.
that's a reasonably new addition, I think, isn't it?
Yeah, well, Ecom have been going around for a little while. We bought Ecom end of last year, basically to integrate with it ourselves because like I said, we've always typically been known as the barriers, PEPPERL+FUCHS, little green boxes in the cabinets, and that's where
There you go.
it's our bread and butter. It's still 60% of our business. But we bought a company for the EXE enclosures a few years ago, so that's sort of been our main growth. And then we've also bought a few years ago a company in America that do the industrial PCs, remote monitors. So these sit in the hazardous area and might communicate to a safe area server, so you can get on your system up there.
Any harmonisation though on UL and CSA and people like that?
I
If
believe
you bought
so.
an American company, you don't have UL.
Yeah. Yeah, it gets a bit difficult depending on what the solution is and where it's going. Some of the units are American, some of the units are German, and so we try and, whenever possible, we try and get various levels of certification, but obviously very costly and time consuming. But yeah, hopefully most of this can go into various different areas.
Builders that one, do you?
No, I've been told, I've never tested it, but apparently it's very rugged obviously. You can even hammer a nail in. I've never tried it, I'm not wanting to because they'll charge me for it. But there's a video I think on YouTube, I could probably bring it up in a minute if people are interested. But the testing that it goes through, I think they freeze it to -20 or so for 3 or 4 days, and they drop 1 kilogram weights on it, pointed from various different heights, and to make sure the screen doesn't shatter and obviously break any housing. So there's a lot of testing that goes into these things. So like I say, we bought them end of last year. We've been integrating over the last few months. So it's Ecom, PEPPERL+FUCHS brand at the moment. Soon it'll be a PEPPERL+FUCHS brand, but it's a German company. Who actually UK head office is at the Wilton Centre, hence why we'll be doing our training there because we can get a free room, which is all good. So yeah, it's quite an interesting addition to our portfolio because from my point of view, I've now got to learn how a mobile phone works and how it integrates in with computer systems, which is completely new to me, but there you go. So yeah, that's typically tends to be where we see things moving forward to anyway.
Are you coming to our exhibition in November?
Yeah, I think we're there. I think it's the week before, is it? First week in November. Is it? I think.
11th or somewhere around there.
8, 9.
Yeah, it's the week before we do it, because I think last year it was the same week, so our planners didn't really work that out very well. So, but yeah, we do it every year.
Good.
Marriott Country Club.
Country
Place,
Club.
isn't it?
8, Wednesday the 8th.
Anything, yeah. So yeah, we'll be there. it'll be myself. I'll see if I can drag one of my colleagues along as well. And yeah, we'll be there. Hopefully see you all around.
I've been out of the business quite some time now. Whatever happened to Basifa?
Good question. They're still around. I believe.
Books are still there.
Yeah.
Is Basifa still certifying?
They do, I believe. Yeah. I think. I'm trying to remember now. I think most of our new equipment is certified through someone else. I can't remember for the life of me the name of them at the moment. But yeah, we still do have Basifa certification on, especially some of the older equipment. I don't know how much we're doing now.
The old equipment, yeah.
Yeah, but I'm not sure. I'm not on the newest. I don't know the exact history, to be honest. So. I believe it's still.
I haven't heard for a long time.
Yeah. Any other questions, queries? No, thank you very much for your time then.
Thank you very much, James. It befalls me to give you a vote of thanks for tonight. I think many of us in the audience here are probably, well, it's quite a few of us have been around since this started almost.
Yeah.
And we've seen it grow, become more complex,
Yeah.
not necessarily become easier to implement.
We were hoping there'll be the day where there's just one standard, worldwide standard, and everything's nice and simple. But until that happens,
And it's become more and more numbers as well, and letters that you've got to accommodate.
Yeah,
But,
well, like I said, in the day training course, Michael Bengals will go through what all the different groups are, what the different temperature ratings are, and actually sort of deconstruct a code, and show you what means what and where it comes from.
But having said that, it's very interesting too how the fundamentals actually haven't changed.
Yeah,
The fundamentals are as they were back in the early 60s,
yeah, pretty much.
when a lot of this, well, flameproof had been around a lot earlier than that, but when intrinsic safety first came to the fore, and when electronics started to appear in instruments.
You didn't need on pneumatics.
You didn't know? Well, no, it was the ultimate intrinsically safe piece of kit, wasn't it?
Flappers and nozzles, didn't you?
Yeah, yeah.
Yeah,
Yeah, I mean,
we even put the flappers and nozzles in the pressurised equipment, didn't we?
But yeah, I mean, the basic technology is pretty much the same in terms of Zeners, definitely.
Yeah.
With the galvanic isolation barriers, the core technology is still the same. It's just all the bells and whistles that you now get, and all the advanced stuff that it does. And that's, there's only so much you can really do with them nowadays.
So thank you very much for reminding us where some of us have come from, where it's got to, and to an extent where it is still going. 'Cause obviously it's still changing. So.
Yeah.
There was one technology we haven't mentioned, that was fluidics. That was going to replace EXIA and EXD and everything else, fluidics.
I thought you were referring to the next part of the evening.
Oh no, I'm being serious.
Anyway, we can present you with a
Oh, brilliant. Oh, thank you very much.
So,
Thank you.
will everybody give James in the normal way, please?
So I've got cards down here, so if anyone wants to take one, send me an email with any questions, queries, or links.
That's what it is. You're going to start if you think anything. Absolutely.
I suppose that's was he at office space?
It's got DC motor in the pit.
We've got 3 guys, I suppose.